In the previous video, we just finished example 4, so let's go ahead and go to the next one. And question 5 says, a standard deck of cards contains 52 cards, and it says that one card is selected from the deck. And in part A, we're asked to compute the probability of randomly selecting a 2 or a queen. Okay, so here's our deck of cards. And part A is asking, find the probability of getting a 2 or a queen when we select one card from the deck. Okay, so first of all, you should notice that that the 2s in the deck are separate from the queens in the deck. So in other words, it's not possible for a card to be both a queen and the 2 at the same time. So in other words, the event of selecting a queen from the deck and then the event of selecting a 2 are mutually exclusive. So to get the probability in question, right, we add up the number of 2s, right, we add up the number of queens, and then divide that by the total number of cards. Okay, so there are 4 2s and 4 queens. Okay, so 4 plus 4 is 8. Okay, so our probability will be 4 plus 4 over 52, which is 8 out of 52. And we can go ahead and put that in our calculator. Okay, so the probability as a decimal is 0.153. All right, and we want to round our answer to 3 decimal places, so 0.153. Okay, all right, so we did the problem correctly, right? What might be the reason that we're getting marked incorrect is if we don't round it properly, okay? So if we round it to 3 decimal places, so 1, 2, 3 decimal places after the decimal point, so the 3 is in the rounding position. So once again, if the next digit to the right is 5 or more, let it soar. If it's 4 or less, let it rest. Okay, so the next digit is 5 or more, so we're going to increase the 3 to a 4, and then keeping the other digits the same. So 0.154 instead of 1.543, or instead of 1.53. Okay, and then part B it says compute the probability of randomly selecting a 2, a queen, or a jack. Okay, then you notice that 2, queen, or jack are all mutually exclusive. So even though it's asking us to find the probability of one or the other or another event, um, the idea is still the same. Okay, so we add up the number of ways that we can get a 2, which is 4. Right, there's 4 2s in the deck. Right, followed by the number of ways of getting a jack, which is also 4, and followed by the number of ways we can get a queen, which is 4, as we saw earlier. So 4 plus 4 plus 4. All that divided by 52. Okay, so we get 12 out of 52. Okay, so putting that in our calculator, so 12 divided by 52 is 0.2307. So rounding it to 3 decimal places, the 0 gets rounded up to 1 because the next digit over is 5 or more, let it soar. So 0.231 would be the answer. All right, and then part C says compute the probability of randomly selecting a 6 or heart. Okay, so in a standard deck of 4 cards, there are 4 suits. So you got the clubs, spades, and then hearts, and then the diamonds. Okay, so those are the 4 suits. So if you want the probability of getting a 6 or heart, okay, so notice that these are the 4 cards that are the 6s in the deck. And then the ones that have the hearts on them are the cards that are heart cards. Okay, and notice that the 2 types of cards have an outcome in common, right? So there's a card that's both a 6 card and a heart card. Okay, so we're dealing with a couple of events that are not mutually exclusive. Okay, but the idea is the same. So we're going to add the number of cards that are sixes, okay, which is 1, 2, 3, 4, and then the number of cards that are hearts. So there are 13 cards in each suit, and you can count them. Okay, so 4 plus 13. All right, keep in mind that when I add the hearts together and the 6 cards, okay, I'm counting the number of cards that are both hearts and sixes. So I'm counting those twice. Okay, so by counting the heart cards and then the 6 cards, right, this card gets counted twice, so I subtract it. So the only card that's both a heart and a 6 is this card here. So I subtract 1. So subtract the cards that are both sixes and hearts, which is 1. Okay, we're going to divide that by 52. All right, so 4 plus 13 minus 1. Oops, 4 plus 13 minus 1. Yeah, that's 16. Okay, so there are 16 cards that are either hearts or sixes. That's 16 out of 52. And don't worry about simplifying the fraction because we're going to put it in our calculator anyway to get the decimal. So 16 divided by 52. So that's 0.3076. So round it to 3 decimal places, that's 0.308. Okay, so 0.308 will be the answer. Okay, and unfortunately I had to reload this, so some of these look a little different than before, but I believe the answer would be the same either way, so 0.308. Okay, so let's look at question 6. So in fact, I'm going to skip over question 6. All right, but essentially what you're doing is you're using the chart to answer the questions. Okay, so I'm going to go ahead and skip over to question 8. And question 8 says the table below shows the results of a survey that asked 2,864 people whether they are involved in any type of charity work, and a person is selected at random from the sample. Now we're going to complete parts A through D. Okay, so in part A, we're finding the probability that a person is frequently or occasionally involved in charity work. Okay, so to answer a question like this, we're looking at the totals rather than the numbers in the body of the table. Okay, so those that are frequently or occasionally involved in charity work would be 423 and then 903. Okay, so these are mutually exclusive, so there are no people that are both frequently and occasionally involved in charity work. Okay, so to get the corresponding probability, we add up the total that are frequently involved and the total that are occasionally involved, and then divide that by the grand total of 2,864 to get the probability. So 423 plus 903, okay, which is 1326 divided by 2864. Okay, and we're going to take that number and round it to 3 decimal places, so 0.463 will be the answer. Part B says find the probability that a person is female or not involved in charity work at all. Okay, so these numbers here represent the females in the sample, and then these numbers here represent those that are not involved in charity work. Okay, so you can clearly see that the events of female and not involved in charity work overlap, so meaning that they are not mutually exclusive. Okay, but we're going to apply the addition rule like we did earlier. Okay, so to find the probability that a person is female or not involved in charity work, we find the total number of females, which is 1,394, and then add to that the number that are not at all involved in charity work, which is 1,538. So 1,394 plus 1,538. Okay, which is that number there. And then we subtract from that those that are female and not involved, which is 743. So minus 743. And then we divide the resulting number by the grand total to get the probability, so divide by 2864. So, so 2189 divided by 2864. And according to the directions, it says we're going to round that to the nearest thousandth. Okay, so if you know your place values, right, this is the decimal point, this is the tenths position, the 6 is in the hundredths position, and then the 4 is in the thousandths position. Okay, so that's our rounding position. Okay, so if the next number over is 4 or less, let it rest. So the 4 stays the same, and then all other digits are the same. So the final answer is 0.764. Okay, part C says find the probability that a person is male or frequently involved in charity work. Okay, so these numbers represent the males in our sample. And then this column represents those that are frequently involved in charity work. So the principle is still the same. Okay, so add up the total number of males. Right, to the total number of individuals who are frequently involved in charity work. Okay, and then subtract those that are both involved in charity work frequently and those that are males. So subtract that number. Okay, and then divide the resulting number by the grand total. And you have your probability, so 0.583, and then round it to the nearest thousandth, so 0.583. Okay, and part D is very similar, so find the probability that a person is female or not frequently involved in charity work. Okay, so you would apply the same principle to answer that question. Okay, and if you need additional practice, okay, I encourage you to look at the examples in the book. Okay, so the examples involve the different types of problems you saw in the homework. Right, and on page 161 is a summary of the different methods of calculating probability that we've discussed so far. So the addition rule in section 3.3, the multiplication rule in the previous section, and then complementary events, which was discussed in section 3.1, the range of probabilities. Okay, so a probability when written as a decimal is always between 0 and 1. And then the different frameworks for thinking about probability, which is classical probability or empirical probability. Okay, those were discussed in section 3.1. All right, and if you ever get stuck on a question, always remember that you can click on Get More Help and then Ask My Instructor, and that allows you to send me a message directly with the question that you're stuck on. Good luck on the homework, and thank you for watching.